Okay, I want to quickly discuss what could possibly be the easiest vulnerability to exploit. There is something called sensitive data exposure, and it's exactly as it says. It's a vulnerability that developers make by exposing some unwanted information in the web page. Now, sensitive data exposure can be something as trivial as showing the application version, but it can also be something as big as exposing perhaps entire database in the web application. And anyone with a little bit of knowledge is going to be able to access it if they want. So it can be a big vulnerability. Now, these type of data exposures don't occur that often, however, you will find them from time to time. Usually, the data will be exposed in the source code itself from the web page. Perhaps multiple developers worked on the website and they left comments for each other in the code regarding some web page details. But if you come across to something like this, well, then there are two possibilities. Either the developer didn't take a single look at the web page before putting it online, or it's made there purposely as a honeypot. And honeypot is something used to catch hackers. Nonetheless, it's most likely going to be the first thing, that the developer forgot to remove his comments from the code. As we can see in this example, there is a comment that says, hey, I put the passwords file in /data directory. Now that could possibly be left for another developer that is going to take over the project. And maybe before they put out the entire website, they forgot to remove it altogether. Now, the plan of the attack is simple, and it goes like this. We search through the code and through the web page. If there is sensitive data exposure, we might find something useful such as hidden directory or an admin page, or perhaps a database. And we use that data to then gain access to things that shouldn't be out there for public to access. Let's see a simple example of this with our Try Hack Me platform challenge. So right here I have navigated to my OWASP challenge inside our Try Hack Me platform, and under the task number 8 we have sensitive data exposure. Now I have already set everything up, I have started my machine, here is the IP address of the machine. If you want, before you do the challenge, feel free to read through all of this and make sure that you read through other parts as well, because the sensitive data exposure has 4 parts. It has task 8, task 9, task 10, and task 11. Now, under the task 11 are our challenges, which we're going to do right now. So, as it says, it's now time to put what you learned into practice. And there's not much to do right here, we just want to copy the IP address and paste it right here. And it will load the page for our challenge. So we can already see that the page is simple. It has some text right here, an image, it has a login button, and it has this button right here that says Sense and Sensitivity. We can click on all the buttons if we'd like, just to see what happens. So if we click on login button, it will lead us to this page where we need to specify username and password. And if we click on this, it will just go back to the main page. Let's try to find sensitive data exposure. If we read through this text right here, we won't really see anything useful for us. As well as on the page itself, we don't really see anything that could potentially give us some more detail than we should have. So let's take a look at the source code. We right click and go view page source. So we take a look at the code. It's just a simple HTML code. We got some directories right here, /login, /assets. And that would pretty much be about it. We don't get any comment whatsoever. Now, we will want to visit these directories in order to see what files perhaps are there. But before we do that, let's also go to the login page and view page source on this page as well. And here we have one comment that says, must remember to do something better with the database than store it in /assets. And remember, /assets is that directory that we saw from the first code, and it appears that they've stored the entire database in that directory. So if we can access it, we have sensitive data exposure, but of course this is to the extreme part, you will rarely see something like this happen, although it does happen sometimes. So let's go to the /assets. And here it is. We got all the regular files such as JavaScript files, PHP files, CSS files, and we also have webapp.db, which stands for database. We can download this file if we want to, save it on our machine, and then we can go through their entire database in order to find out some information, perhaps about users, about their private data, and other things as well. And we're going to do that right now. So let's open a terminal. Let's navigate to the downloads directory where we downloaded our webapp.db. And in order to navigate through this database, we can type the command SQLite 3 and then webapp.db, which is the name of our database. We press enter and it will open this SQLite interpreter where we can type in our SQL code. So first thing with this database, we want to see all of the tables that it has. And we can do that by typing the command dot and then tables. If we press enter, we get two output right here that says it has sessions table and users table. We're more interested in this users table since perhaps maybe there are passwords there. So what we can do is we can run the SQL command to select everything from this table. And the command would go like this: select star, and star simply just stands for everything, and then from, and then the users. Let's not forget the semicolon at the end, and if we press enter, we get this output right here. Now, before we discuss this output, let's go back to our task and see what we need to submit. So the first thing that it asks us is what is the name of the mentioned directory. We can already specify the answer, which is /assets, submit that, and it's the correct answer. It says navigate to the directory you found in question 1, what file stands out as being likely to contain sensitive data. And in our case that is webapp.db. Let's submit that as well. And use the supporting material to access the sensitive data. We already did it. And the question is, what is the password hash of the admin user? So could it be that these are the password hashes? Well, they most likely are. We're in the database and usually databases store passwords in hashed value and not in plain text. So we can copy the hash and specify it to see whether it's the correct answer for the user admin. Let's go right here and paste the hash. And it's the correct one. Now it asks what is the plain text password from this hash, so we must crack it first. We can do that with the help of an online website. We can navigate to a website like crackstation.net. And here we can type in our hash, which hopefully will get cracked by this website. Down here it says which hash types does it support, and they probably have a huge database with a bunch of plain text passwords that they run our hash against and see whether they found a match. So let's paste our hash right here. Let's click I'm not a robot. Let's select all the bridges, verify, and let's click on crack hashes. And we get the output. Our hash is the type of MD5, and in plain text it is QWERTY UIOP. So this is the password in plain text for the admin account. Let's copy it, go back to our page, and let's type admin and then the password that we just cracked. And here it is. We found the flag for our challenge. Now we can submit both the plain text password and the flag right here. Awesome. So this was an example of sensitive data exposure. And we're not going to take a look at more examples because this is pretty much what it will always be. You search through the web page and through the code. If you find something useful, you use it to gain access. If it's, of course, something as big as database exposure or passwords exposure. In other words, this is not a technical vulnerability, it's strictly bound to developers making a mistake and leaving something out there for public to see. Nonetheless, thank you for watching, and in the next lecture we're going to tackle another vulnerability type which is called broken access control. See you in the next lecture. Okay, broken access control. What type of vulnerability is this? Well, before we define it, let's first see what access control itself is. Access control is how web application grants access to content and functions to some users. Notice that I said to some users, so not all of them. Access control is part of the application that decides who gets to see which content and who doesn't. Sometimes access control can be strictly tied to authorization and session. And in some cases, it might even be the exact same vulnerability as broken authentication, which we already covered. However, there is more to it than that. Once we covered broken authentication, we mostly focused on breaking the session and the authentication of the user. Broken access control, on the other hand, can also target not only sessions, but for example, different files or directories on the web page. Perhaps some users have access to certain files that are on the web page and the others don't. If the access control is not performed properly, we could also get access to those files. Same goes with directories. Perhaps there are some directories that are only meant for admin to use and visit, but they have no access control and can easily be visited by adding the directory name to the link. This is also a broken access control vulnerability. Besides different files, it might also allow us to see other user information. Now, all of this is once again due to developers' mistake. If the access control is not implemented properly, then you might have the broken access vulnerability. And it could look something like this. Let's say we have a random site that has a function to choose a file and perhaps download it on your machine. Choosing a file should have its own access control. We can assume that this randomfile.php is stored somewhere on the server. But so are all the other files that we don't have an option to download. So, have they implemented a good and valid filter that will only allow us to download the files that they offer? Well, we can find out if we try something like this. What if we type, instead of randomfile.php, we type in /etc/passwd. If we get the output of the passwd file, or if it downloads it to our page, we have an example of broken access control. We downloaded something that we should not have been able to. This type of vulnerability can also be called IDOR, or in other words, Insecure Direct Object Reference. This vulnerability occurs when an application uses user-supplied input to access objects directly. And we will see more examples about it in the practical lessons. So let's first of all start with our TryHackMe platform. Okay, here we are on our TryHackMe platform and we have the broken access control challenge, which is task number 18. Now, as usual, I advise you to read through all of the broken access control tasks, which in this case is task number 17 and task number 18. I have already started the machine. Here is the IP address to the machine, and now we need to perform these challenges right here. So let's first of all navigate to this page by copying the IP address and pasting it right here. So note viewer, what user are you? And we have the field to log in with username and password. Let's check whether they supplied us with some information as to how to log in to this page. And here it is. The username is Knut and the password is test1234. Let's type that in. And let's submit this. And it gives us a rather simple page that only types out I am Knut with the exclamation mark. But if we take a look at the link, we have this parameter right here that says note equals 1. And this is the parameter that we can try to tamper with. We can conclude that this parameter could have something to do with the user ID, for example. Maybe this parameter that equals to 1 is strictly made for our Note account. So what would happen if we change it to 2? Well, we don't get anything. What would happen if we change it to 3, for example? We still don't get anything. Let's try changing it to 0. Press enter. And here's the flag. We got the flag from a different account, which means that we have an example of broken access control vulnerability on this virtual machine. Now, this was rather easy. All we had to do is change this parameter right here, but it's all possible due to them not filtering our input correctly. They don't have any control over this parameter as to what the user can do with it. In real web applications, this input right here should be very well filtered that if you try to change the session or try to change the user ID, it just goes back to your own account. It doesn't let you see the information from different users. And in our case, this is our flag that we need to specify as the answer. Look at the other user's note and let's paste the flag, submit it, and it's the correct answer. Okay, so this was rather easy. Now let's look at some a little bit more difficult examples on our OWASP BBA virtual machine. See you on the next lecture. Welcome back. Let's see another example of IDOR vulnerability. So in the previous video we saw a simple example of tampering with one parameter in order to change the user ID, or in order to be able to see private information from a different user. Right now let's see what examples can we get on our OWASP BBA. So first example that I want to show you is on OWASP Mutil-Date 2. So let's click on that. And here, as usual, under the OWASP 2013, we will have this vulnerability that says insecure direct object reference, or in other words, it's the IDOR vulnerability. This is an example of a vulnerability that I showed you in the theory lecture. Now let's put it to practice. Let's go to any one of them. So for example, let's go to source viewer. And in this simple page, we have a source file name to select, and it tells us to see the source of the file, choose and click view file. Note that not all files are listed. Okay, so let's choose any one of them. For example, let's go with register.php, click on view file, and it gives us the output of this PHP file. So pretty standard. But once again, remember from our theory lecture, we must ask ourselves the question, is this or are these files that we have in this list the only files that we can read? Well, in this box we can't really type any other file name, however we can intercept this request with our burp suite and try to change the file. Let's go to our burp suite, turn on the intercept, and let's select any file whatsoever. Let's go with login.php and click on view file. So we intercept the request right here, and down here in these parameters we have the PHP file parameter that selects which page we want to view. Now since we can't really type it in right here, we're going to type it in inside of our burp suite. So let's delete login.php and let's for example type /etc/passwd. Let's see if this will work. If we forward this packet, turn off the intercept, go right here, well, here it is. We have the output of the @c/passwd folder. And once again, that is the broken access control vulnerability. We got the output of a file that we shouldn't be able to see. Now, same goes with this parameter right here in the page. This is simply just parameter that selects which task are we currently doing. So if we go to insecure direct object, you will see that the page name is source viewer, and it probably has some PHP file that processes this page. But we can also try to go and perform broken access control right here. if we type /etc/passwd for this parameter, well, we get another output and another broken access control vulnerability where it outputs once again the passwd file. And it's the same with all the other examples. So for example, if we go to cookies right here, we can inject our etc passwd right here in this page. Oops, I misspelled passwd. And once again, here is the output of the etc passwd file. So this type of vulnerability is not that hard to perform. Of course, it might have some filters that might protect it to some extent, and those filters we're going to see in the next video with a different example. However, usually once you have this vulnerability, it will most likely not have any access control whatsoever, therefore you will be able to access different things that you shouldn't be able to see. Okay, awesome. Thank you for watching this lecture, and I will see you in the next lecture. Welcome back. Let's discuss another IDOR example inside of our OWASP BWA machine. So in the previous lecture, we took a look at the IDOR challenge where we changed the file that we want to view to /etc/passwd. And that way we displayed the file that we shouldn't have been able to access. Now let's take a look at a different type of IDOR challenge inside of our BWAP application. Click on that. And as usual, let's log in with our credentials, which are b-and-bug, and click on login. We have our current security level set to low, and we're going to leave it on low for now, and let's choose our bug. So navigate to IDOR challenges, which are right here, and out of these three, we're going to go onto this one, which says insecure door order tickets. Click on hack, and it will lead us to this challenge. So it's a simple application. It asks how many movie tickets would you like to order, 15 euro per ticket, and here we can type in how many tickets we want to order. For example, if I want to order 10 of them, and click on confirm, it will tell me that I have ordered 10 movie tickets and that the total amount charged from your account is 150 euro, or simply 10 times 15 euro per ticket. Okay, let's see whether we can manipulate this and perhaps change the price. So first thing that we're going to do is we're going to turn on our intercept, and here let's go with 10 tickets once again. I will click on confirm, and this is the request that we get. Down here we can see all of the parameters that are being submitted with this request. So we have the ticket quantity equals 10, we have ticket price equals 15, and the action equals to order. Now this is a constant. We know that the price of a ticket is 15. So perhaps with the IDOR vulnerability, we can try to change the price of this ticket. So instead of 15, let's just leave it on 1. Let's make the price to be only 1 euro. And let's see whether this will work. If we forward this request, go back to our page. Well, here it is. It worked successfully. We ordered 10 movie tickets, and the total amount that was charged was 10 euro. So we pretty much ordered 10 tickets for the price of 1 euro per ticket. Let's also see how this would look on medium security level. Let's click on medium, and let's click on set. Oops, we still have our intercept turned on. Let's turn it off and let's go back to our page. And now let's see how our application is acting. So if we once again specify 10 tickets and we click on confirm, well, it doesn't really appear that anything changes from the low security level which we had previously. We still get the output, you ordered 10 movie tickets and the total amount charged is 150 euro. But let's see, are there any differences in the HTTP request once we intercept it? So let's turn on the intercept. Let's once again try to buy 10 tickets and let's confirm it. And this is our request. you will notice that we no longer have the ticket price parameter inside of our request. So how are we going to change the price now? Well, we can take a look at this ticket quantity. The ticket underscore quantity is a parameter for how many tickets we want to buy. And we can assume that perhaps there could be a ticket underscore price parameter that could be set to the price of a single ticket. So maybe we can try to input it ourselves right here and see whether that would work. As we can see, these parameters are being separated by this sign, and let's give it a try. If we type that sign and then ticket underscore price equals 1, let's try to set it to be equal to 1. Let's see if us injecting the parameter manually will make any changes on the page. If we forward this, go back, and there it is. We made this work successfully. We ordered 10 movie tickets for the price of €10, and once again we managed to perform the IDER vulnerability on medium level. Now, on high level, I believe all of these applications actually show the secure code, so I'm not sure if it's possible on high level, but let's give it a try. Let's confirm with one ticket, and the price for one ticket is €15. Now, if we intercept that, well, we get pretty much the same response as from the previous medium security level. So if we try the same thing, ticket price equals to 1, and we forward this, well, it won't really work. And this is because high level is usually a secure version of these applications. But we can always do something like this. If we have intercept turned on, and we go on confirm, what we can do is we can try something like this. So let's inject ticket price to be equal to 1, and let's change the security level to be equal to 0. Now if we forward this, well, now we once again changed the price to 1. But we cheated a little bit. We exploited a different parameter inside of our request, which changes the security level. Nonetheless, this is another example of IDER challenge, and in the next lecture we're going to take a look at security misconfiguration vulnerability. Welcome back. Let's discuss security misconfiguration. Now, in this lecture, we're going to check out default credentials vulnerability. Now, you might be asking, well, didn't we already do that? And isn't this something that belongs to broken authentication or brute force attacks or something like that? Well, it's a little bit different. We covered guessing default credentials and brute forcing pages of client profiles. Now we want to take a look at default credentials vulnerability for an application that is implemented in the web page. So this is not a user account on a web page or something like that, which a user sets up. This is something that the server owner and the web page owner sets up once using an application within a web page. So we have a simple example right here in our OWASP top 10 on our Try Hack Me challenge, and we're just going to cover it in this video, and then we will move on to a different vulnerability, because this is once again just default credentials vulnerability. It's rather easy to perform. All you need to do is try to find the default credentials for a certain application. Nonetheless, let's go all the way down, and here it is. Task number 19, which is security misconfiguration. Now, let's start our machine straight away. And if you'd like, you can go and read through all of this. We also see that it does mention default passwords as one of the security misconfigurations, whether it's once again from the user's perspective or from the server's perspective. In both ways, there shouldn't be any default credentials on the web page. However, this is something that developers are responsible for because they didn't really change the default credentials on the application that they host on their website and that anyone can access to. While our machine is starting, let's read through our challenge. This VM showcases a security misconfiguration. Deploy the VM and hack in by exploiting the security misconfiguration. Okay, so they didn't really tell us anything important. All they said is to deploy the VM and find the flag. Let's wait for a couple more seconds for our VM to start. And once we get our IP address, let's copy it, go right here and paste it. Okay, so this is the application that it opens. We have a login screen, we have swap theme, which doesn't really do anything, and we have change password. If we take a look right here, we also have this sign that says Pensive Notes. And it tells us down here, Pensive Notes, a note-taking app for people who like to think about their notes. So we already know this is an app. Let's try to perhaps Google it. We go Pensive Notes inside of our Google. And the first thing that we see is a GitHub project that is called Pensive Notes. Let's click on that. And we get the same message that we got on our web application. Pensive Note is a note-taking app for those who want to think and reflect about what they write later on. So we're on good place. This is the app that we're looking for. If we go to Information and Installation, down here we will find this sentence that says, after downloading and compiling Pensive Notes, log in using the default credentials, Pensive and Pensive Notes. So we found default credentials. Let's see whether they work on our application. If we type Pensive and then Pensive Notes, well, it does have default credentials. And we get our flag right here. So this is another security risk that could happen once a website is using some type of an application that has login form. This can also happen on something like Tomcat, on PHP, and all of the other services that website can have. Nonetheless, I just wanted to mention this is another possible vulnerability and that it differs a little bit from regular default credentials that a user on a web page can have. And now that we're done with this, we can move to the next vulnerability, which is called XSS. Thank you for watching, and I will see you in the next lecture.
Hey everybody, I want to take a quick break here. Go grab a coffee, grab a tea, just take a break from all the learning that you just did. And I want to talk to you quickly about imposter syndrome. It's this idea that you're not good enough, that things are too complicated for you to ever achieve what you want to achieve. You look at other people, at other industry experts, and you say, I will never get there. But it's just a symptom of learning. This idea of you not being good enough simply means that, well, you're just not there yet. Things take time. If you want to learn a valuable skill, well, it's hard work. That's why it's valuable. Remember how you felt on the first day of going to school, first day on a job. It's the same experience. But over time, with repetition, with practice, you get comfortable, you get experience, and you slowly start to lose that imposter syndrome. Now, this idea of an imposter syndrome is great. It means you're doing something worthwhile. So don't use it as a negative. Use it as an encouragement that you're doing something good, that you're learning and you're stretching your limits. So with this break, I want to propose that we do a quick exercise. I want you to stop the lectures, again, grab a coffee, grab a tea, and head on over to our Discord. Now, in our Discord server, if you've used it up until now, that's great. If you haven't, head on over to this server, and I want you to do something that I think it's super important to learning. And that is using what you've learned up until now to actually teach someone or help someone. So you can go all the way to, let's say, the coding and courses section and pick a topic that you want to help somebody in. So let's say you go to the Python channel. And in here, you'll have other students that are asking Python-related questions. Now, you can scroll through here and see if you're able to help someone. Even though you may not have the experience or the knowledge yet, this idea of practicing and explaining what you've just learned to other people, even if you're not 100% certain, actually is beneficial to your learning. Because if you're never teaching, if you're never explaining and vocalizing and showing what you've learned, you'll always be a beginner. This idea of teaching what you learn is a very important concept. So moving forward, as you go through the lectures, anytime you feel like taking a break, hop on over to Discord and help somebody. Our motto here is that we're always kind. We don't judge anybody. We're all just beginners here. We're all learning. So don't be afraid to answer things, because you got to remember, nobody's perfect except for Yoda. Yoda is pretty perfect. All right, I'll see you in the next one. Bye-bye.
It's time we get started with biggest vulnerabilities or bugs on a web page. Now, by biggest, I don't mean most dangerous. However, these ones are still not something that you want to have on your web page. We will be starting in this section with cross-site scripting vulnerability, or also known as XSS. Now, you might have noticed that in the upper right corner, we have this JavaScript icon. This can give us a hint as to what this vulnerability is. So, let's explain it. First of all, XSS is very similar to HTML injection. Those two are executed almost the same way, and since we already covered the HTML injection, this will be a lot easier for you to understand and perform. XSS is based on injecting JavaScript code in the web page. As with the HTML injection, we're looking for a vulnerable user input field that reflects our output somewhere on the page. Once we find it, we try to inject simple JavaScript code to see how the page would react and whether it would execute it. One thing to keep in mind is that XSS is not a vulnerability that targets server. It is a vulnerability that targets clients that use that server. If we are able to inject our malicious JavaScript code in the web page, then that JavaScript code will also run once a different client visits that web page. Now, whether the client visits the web page directly or through a link makes a difference depending on what type of XSS vulnerability it is. And we will discuss different types in just a second, right after we discuss the process of why our JavaScript code executes on a vulnerable web page. So imagine we have this code as an example. It's the same code that we showed inside of our HTML injection, just this time instead of injecting HTML, we want to try to inject JavaScript. And the most simple thing we can run with JavaScript would be the alert function. Of course, once embedding JavaScript inside the HTML code, we must add the open script tags where our JavaScript code starts and close script tags where our JavaScript code ends. This is how the browser will know that it's JavaScript, so it doesn't try to render it as an HTML code. This code being a simple code that asks for someone's name and then reflects it on the page would look something like this once we inject our alert function. And if the website doesn't filter the input, it will process this as JavaScript code and we will get a small pop-up window which is tied to this alert function. That's when we would know that there is an XSS vulnerability. Of course, web page can also have filters that are not properly set. Usually a page can have a filter that says everything between the HTML tags where the user input gets reflected, process it as a regular string or regular text. To bypass only that filter, we could then do something like this. We can first close tags for that line and then run our JavaScript code. In this case, the end closing tag will get left out and it will no longer consider our script as being a part of the open pre-tags. Of course, this is all working considering there are no other input filters. Now, let's talk about two main types of XSS and how they differ. These two types are called reflected XSS and stored XSS. Let's explain reflected XSS first. In reflected XSS, we have an attacker injecting JavaScript code inside a certain web page. The web page processes that input as JavaScript and runs it, letting the attacker know that it's vulnerable to XSS. Then the attacker sends the link to that web page with the JavaScript code set as an input to the vulnerable parameter. Once the target opens the link, it will also run the JavaScript code on the vulnerable website. The XSS where the JavaScript code we inject doesn't get stored and saved on the server is called reflected XSS. On the other hand, stored XSS is the exact same attack, just this time our JavaScript code gets saved and stored on the server and on the web page. This can be perhaps a web page that offers comment section. If we inject JavaScript code in the comment section, it will run every time someone opens that page. And that's the main difference between these two. In stored XSS, target doesn't have to click on any link at all. They can just go straight to the web page and it will run nonetheless. The stored XSS is more dangerous since it doesn't require the target to open any links, they only need to go to that website. Now, besides these two, there is also something called DOM XSS, or DOM-based XSS, and it's an XSS attack where the attack payload is executed as a result of modifying the DOM environment in the victim's browser used by the original client-side script so that the client-side code runs in an unexpected manner. We will see examples of different XSS types throughout this section. Since this is one of the most common vulnerabilities on a web page, we will devote a little bit more time to it than to other vulnerabilities. Welcome back. Now that we learned what XSS is in theory, let's see different examples of how we can use and exploit the XSS vulnerability. We're going to start off as usual with our TryHackMe platform. So, I already have my machine started right here. I have navigated to task number 20, which says cross-site scripting, and we have a couple of options right here, or a couple of tasks, should I say. We have to solve all of these challenges. And I also advise you before you do that you can read through this theory part right here and maybe learn a thing or two more about XSS. Nonetheless, once you do that, copy the IP address of your virtual machine and paste it in your browser. Okay, so we got a simple page that has a login form, a register form, and it has some options right here where we can go to reflected XSS or stored XSS. Let's see what our first task is. The first task is to deploy the VM. We already did that. The second task is navigate to our IP address in your browser and click on Reflected XSS tab on the navigation bar. Craft a reflected XSS payload that will cause a pop-up saying hello. Okay, this sounds like a simple task. So let's go right here and let's navigate to the reflected XSS. As we can even see right here, our task is to create a payload that will pop up a message that says hello. And we can do that with the help of a JavaScript alert function. The same one that we covered inside of our theory video. So all we have to do is, well, let's first see what would happen if we type just test. So it will reflect it right here on the page. It will say you searched for test. Now if we type our JavaScript code, and the function that we use is once again alert in order to specify the alert message. In our case, the message will be hello because that is our task. And we close the script tags, we click on search, and here we have an XSS. It ran our JavaScript code and opened this window that says hello. Okay, let's click on OK, and we get our flag right here. So this is the flag to our challenge. Let's copy it. Let's go back, specify it right here and submit it. Okay, awesome. Let's close this and let's see what our second challenge is. So on the same reflective page, craft a reflected XSS payload that will cause a pop-up with your machine's IP address. Okay, so we pretty much use this same user input, so we know it's vulnerable to XSS. Now we need to run a different JavaScript code in order to pop up an IP address of the virtual machine. We can do that by typing this script right here. And let me just zoom this in, just so you can see it a little bit better. We run script, and then inside the script tags we type alert, and in between the brackets we specify window.location.hostname. And of course at the end we close the script tags. So this is how our script would look like in order to pop up the IP address of the virtual machine. Let's click on search, and here it is. We get it right here. Click on OK, and we will get our flag, which we specify as a result for our challenge. Let's go right here, paste it, submit it, and that one is correct as well. The second thing, or pardon me, the third task that we have is navigate to the same IP address in your browser and click on Stored Access As. And we also need to make an account. So let's do that real quick. Let's close this. Navigate to Stored Access As. Remember, the reflected accesses only reflected our JavaScript code on the page, it didn't store it on the server. With the stored accesses, we're going to see an example of our JavaScript code being stored on the server. But before we do that, let's register as a user. We type test, and as a password we can use test1234. Let's register. And we are currently signed in as test user. Now we could have maybe used an XSS on this part right here as a username because it does get reflected on this page, but this is not a part of the task. That is something that you can try after we finish this video. For now, we want to navigate to Stored XSS, and it appears that we have a simple comments application. If we type hello right here, post a comment, here is our username, and we said hello in the chat or in the comments. Now let's see what our first task is. We want to add a comment and see if we can insert some of our own HTML. So we're already comfortable with HTML and HTML injection, so this is already something that we know. We can try to type open header tags, test, and close header tags. And here it is. We also have the HTML injection, and the answer for this question is this HTML T4GS. Let's specify it as the answer right here. And let's move on to the last two challenges in this video. So on the same page, create an alert pop-up box appear on the page with your document cookies. Well, we already know that we're going to use the same alert function. So let's open our script tags. And in between the alert brackets, we want to specify document.cookies in order to alert us with our cookie values. We of course need to close the script tags, and once we submit this comment, we get our cookies right here. And this is also stored XSS. We will get our result or our flag right here, which for some reason I can't seem to copy. Let's try it like this, paste it, and it works. Now, if I refresh this page, you will notice that due to this being a stored XSS, this will pop up every time I refresh the page. And not only every time I refresh the page, but every time someone else visits this exact same page, they will get a pop-up with their cookie value. And that is because this is a stored XSS. A stored XSS gets stored on the server, and this value right here of our HTML injection and our value of our JavaScript injection or XSS vulnerability is also getting stored on the server and loaded every time someone opens this page. And that is the difference between the reflected XSS and stored XSS. This one we can say it's a little bit more dangerous because it's getting stored on the server. Now let's go with our last challenge. It says change XSS playground to I am a hacker by adding a comment and using JavaScript. We have the XSS playground right here, and we want to change this into I am a hacker. This can be a little bit tricky. We want to find the ID of XSS playground and we want to change it to I am a hacker. We can find the ID by going to Inspect Element. Then we want to navigate to this part right here. And it's in the navigation bar. Lower that. Open our div tags. Open our A tags for the Access Playground. Right here we should be able to find the ID of the Access Playground, and it's right here in this line. The ID equals THM-title. So that is our ID. Now I want to call it with our JavaScript injection. So let's go down here. Open our script tags. Let's type document dot, and we're going to use query selector. And in between the brackets, we specify the ID of our Access Playground, since that is what we want to change. We need to specify it in between the single quotes, then we add a hash, and then the ID name, which is THM-title. So we change it like this, then we add dot, and then text. Content equals, and now we specify what we want to change it to. For our challenge, we must change it to I am a hacker. And at the end, we close the script tags. So this is our payload. If we specified everything correctly, it should change this Access Playground into I am a hacker. Let's click on comment. We get loaded with these values. And for some reason, oh never mind, it worked, we managed to change it, and now it says right here, I'm a hacker, and we successfully completed the challenge. If we take a closer look at this page, we also get this right here, which is our flag. This is a flag that means that we successfully completed this challenge. Let's specify it right here, and let's submit it. Okay, awesome. I do admit this last task was a little bit harder, but we managed to get through it. We used the query selector, and then we selected the ID of the thing that we want to change, and we used the text content in order to write the I am a hacker sentence. Awesome. Nonetheless, we finished with try hack me example of XSS, and we're going to move to XSS examples inside of our BVA virtual machine. See you in the next lecture. Welcome back. Now I want to discuss a reflected XSS on our DVWA page. Now, there we have a certain level of security that we can set, and we're going to take a look at how we can bypass the medium security level on this page. The reason we're not covering the high security level is because in the latest updates, high security level is set to be impossible to hack. It's actually set to the correct code as to how secure pages would look like. Let's go to our DVWA. Let's log in with admin and admin. And here we first want to check what security level we'll have. Currently we have low. Let's leave it like that for a moment. And let's navigate to the XSS reflected. So we get a simple application. It asks for our name. If we specify test, our usual string, it says hello test. So we already see it's getting reflected on the page, and it becomes interesting for us to test for both HTML injection and XSS. Let's try with a simple alert function. So let's alert hello, and let's close the script tags. As easy as that was, we get our alert window pop-up right here that says hello. Okay, awesome. But let's give it a try on a medium level. Will that same example work on this level? If we change it to medium and submit, then navigate back to XSS reflected and type in the same thing, close the script tags, and I submit, we get hello alert and hello inside of our brackets. But where are our script tags? Well, perhaps they got filtered, and by this output we would assume that they did indeed get filtered and removed from our input. If we want to cheat a little bit, we can take a look at the source code that will tell us exactly what this page is doing in order to filter our input. And for practices, that would be a good thing to do. Let's open this PHP code. And if we take a look at right here, here is where filtering happens. We're getting our script tags replaced with nothing. Interesting. But we can't run our JavaScript code without the script tags. So does this mean that this is a secure input? Well, not exactly. If we try to do something like this, and we type in capital letters script, and then alert hello, and we close capital letters script, we submit this, well, this worked. We only changed the lowercase letters into capital letters and it managed to bypass the filters of this page, because by their PHP code, they're only replacing lowercase script tags with nothing. If we type uppercase script tags, then it will work. So how easy was that? And believe me, many pages have this type of a weak filter where they only filter some things and not all of them. Nonetheless, thank you for watching, and in the next video we're going to take a look at the stored XSS on DVWA page. Okay, we're starting off where we finished from the last lecture. We managed to bypass a simple filter on our XSS reflected page. But right now, we want to see how we can also exploit the XSS stored on DVWA. So, navigate to the stored XSS, and this is the application that we have. It's a comment section. We type in our name, and the message, hello world, and we sign the guestbook and it will add it right here on the page. We already know that these comments are getting stored on the server, so anyone loading this page will also see our comment. Same goes with the JavaScript code that we inject. Anyone loading the page will also load our JavaScript code, because we injected it straight into the web page storage. Now let's try on low level to execute our JavaScript. So let's go to DVA security. Let me change it to low and navigate back to the store XSS. Let's try to inject both fields. If I try to continue to type in the name field, it won't allow it. I guess it has some filter of how many characters we can input. So let's just try to go with test right here, and let's inject our JavaScript code or our simple alert function in the message field. If I sign my guestbook, and let me just load this a little bit more so you can see it better, then I click on sign guestbook, well, here it is. On low level, it's really easy to exploit, it has no filters at all, and all we have to do is type in our script tags, alert function, and it will run on the page. Now let's give it a try on the medium security level. If I type submit, go back to the stored XSS, we load our previous alert window because it's stored on the page, and now let's try again. If I type test, and a simple alert function between the script tags, well, the window that we just loaded was from the previous low-level security script. If we manage to execute this one, we would get two windows. And just so we can differentiate them, let's run the script alert, and in this window we're going to type in hello, just so it can different from the previous script that's already stored on the page. As you can see, this is not the one that we just ran, it's from the previous attack. The one that says hello is not getting executed. Now, if we take a look down here, it appears that our script tags are getting removed, and also we are getting these backslashes before our single quotes. So it's getting filtered. But let's try to inject inside of the name field. If I type here script alert, and we know that we have the character limitation, but Let's just leave it like that for a moment and sign the guestbook. Our script tags appear to be filtered as well. So what are we going to do? Well, let's take a look at the source code of this page. Let's see how it performs the filtering. So this is the code of this page, and we have a part of the code that sanitizes the message input and a part of the code for the name input. Now, by looking at the message input code, I can already see that this is getting filtered a whole lot better than the name input. Why? Well, because it has this HTML special chars function that removes all the HTML characters from our message. But this is not being used on our name. We only have the same filter that we had from the previous video inside of our name input. But we do have another problem. We have character limitation inside the name input. So how are we going to bypass that? Well, we can do something like this. We can type script alert and we get to the character limitation. So in order to bypass it, we go inspect element. We find this name input inside of our code. It's in this form. Let's open the table. Open the body of this table, and it's right here. It's this line that I have selected. And in this line we have max length equals 10. So if I double click on this and change 10 to 100, press enter, now I go back and I can continue typing in this field. Now I can type the entire script statement. And remember, our script tags are getting filtered, so we're just going to bypass it the same way that we bypassed it in the previous lecture by adding capital letter script. And if I click Sign Guestbook now, we'll load the first alert from the low security level. And it doesn't appear that we loaded the second alert. Let's give it a try once again. Of course, we need to increase this to 100. We type uppercase script tags and alert, and let's just differentiate it by typing hello in the brackets. Close the script tags. We can type anything in the message since that is getting filtered well, and we sign the guestbook. Here it is. Here is our alert script getting executed. We get our message hello. So it worked perfectly. Now I want to show you another thing that you can do with XSS or with HTML injection in general. You can inject a link for a file download. For example, for the purposes of this, I'm just going to go back to low so I can inject it in the message field. Go back to stored. Here we load our to XSS, and here I'm going to type test, and to inject a code that will allow the user to download a file from your command, we can type something like this. Open a tags href equals, and in between the double quotes we specify the link that will lead to the file that we want the users of this page to download. So for the purposes of this, what we can do is we can, for example, go to this PHP info, copy the path to this file. Let's copy it, go back, and paste that path right here between the brackets. So open a tags href equals this link, and now we want to type space download. Oops, we also have character limitation right here, so we can bypass it the same way that we did previously by finding that in our HTML code and increasing the max length to 100. Now if I type download till the end, it will work, and I close the tags and type the file name. So the file name could be pretty much anything that we want. We can just call it php info.php. We close the A tags at the end, and we sign the guestbook. Let's click on OK. And here it is. We injected a link for file download. If I click on it, it will ask me whether I want to save this file on my PC. So that is also something that you can do with this vulnerable input. Whether you inject an HTML code that will download a file or JavaScript code that will download a file, it doesn't matter. What matters is that the possibilities with this are limitless, especially when you can inject JavaScript code. Okay, awesome. Now that we covered both reflected and stored XSS on the DVWA, let's take a look at the DOM XSS on our Mutil.de page in the next lecture. Welcome back. Let's discuss a DOM-based XSS. So, in the previous few videos, we covered a couple of examples of reflected and stored XSS. We also saw some of the possibilities, such as stealing cookies, getting the IP address, changing the contents of the page, and also injecting a file to download. We also bypassed filters that removed our script tags, and we managed to bypass the max character security. Now let's navigate to the password generator in DOM XSS vulnerability. You can do that by going to OWASP, then navigating to cross-site scripting, and under the DOM injection, you want to select password generator. And this password generator, once we click on this simple button, generates a random password every time. Now, the first thing you will notice with DOM XSS is that if you tried to intercept this request, it will not work. You're not going to intercept anything once clicking on that button, even though the intercept is turned on. That's because no requests are being sent. As we can see, nothing is happening, so we can turn this off. But if we take a look closer at the link, we'll have this username equals anonymous. So let's try to inject it. If I type our usual alert function by opening script tags and closing script tags, press enter, it doesn't work. At least we think that it doesn't work. We didn't get a pop-up window, but what we did get is this part right here. And this looks like a part of code. So let's try to find in the source code where exactly is this located. Let's open page source and let's copy this, for example, and let's try to find it right here. We can't seem to find it. Let's try just finding it manually. Or we can try to find all of the alerts on this page. Here is one alert. Here is another alert, and here is where our code is getting injected. This is the error message that we get, as we can see right here, and this is our code that we injected. So it's still getting there, just it's not getting executed. Let's see why it is not getting executed. Well, if we take a closer look at this part of the code, we will notice that we already have open script tags. So our JavaScript code is actually getting injected inside our JavaScript code. That means these script tags are not needed, or we need to specify close script tags before we open them to run our alert function. So how can we bypass this? Well, since we already have open script tags, we can just first close the script tags for this part of JavaScript code from the page, and then we can open the script tags once again to run our alert function. Let's give it a try. If I go to this page, I delete my previous payload. What I'm first going to do is I'm first going to close the script tags. And then I'm opening script tags right after, then typing my alert function. Let's specify hello as the pop-up message, and I close the script tags again. So this is how our payload looks like right now. If I press enter, now it's getting executed. Now we managed to run our JavaScript code by closing the previous JavaScript code and opening the new alert JavaScript code. Let me show you how that looks like now that we ran it successfully. Let's try to find our alert function once again. And here it is. As you can see, the script tag that is getting opened by the code itself is getting closed by us right here. Here is our closing script tag. And right after we did that, we opened another JavaScript function that will run the alert message. Then we closed it, and the thing that we see outputted right here as an error is actually a part of code that we get right after we close our script, because this is no longer belonging to these JavaScript script tags. This is getting processed as a regular text on the page, therefore it's getting outputted right here. So we managed to execute our JavaScript code by taking a look at the source code and seeing what we need to adjust in our payload in order for it to be able to execute. Awesome. Now that we did that, we're going to take a look at another example of XSS, or a different example of XSS, in the next lecture. Okay, we went through a bunch of different XSS attacks, but on our OWASP BWA machine, we have even more examples of different XSS possibilities, and if I were to choose on which of these applications that we have available, on which one we have the most examples of XSS, I would go with an application BWAP. On BWAP, we have most XSS examples, and I advise you to go through all of them just so you can practice this vulnerability even more. We're going to cover 2 or 3 at the beginning, and then I will let you go through the rest of the attacks. So we're already familiar with this app. We log in using B and Buck as username and password, and here we choose our vulnerability. If I scroll all the way down, here are all of the XSS attacks that this application offers. And they're all different. As we can see, this is an example of reflected GET request XSS. This is an example of POST request XSS. We have JSON XSS, and we have a bunch of others as well. Towards the end, you even have some stored XSS examples. Let's start with first 3, and let's see how we can solve them. So let's click on Reflected XSS, click on Hack, and here's the application. So enter your first and last name. So let's enter first name test1, last name test2. We click on Go. Nothing happens. The only thing that changes is that it prints out welcome test1, test2. So both of these fields get reflected on the page. We can try to inject both of them with alert script just to see if they both execute. So let's type alert hello, and let's close our script, click on Go, and of course we get 2 different pop-up windows for both of our alert functions. So both of these inputs are vulnerable to the XSS attack. Once you go through that one, we can navigate to the next one, which is post request XSS. And in this one, we get the same application, just if I type test1 and test2, we get the same output, but our parameters are not being sent within the link. So we will not be able to inject our JavaScript code inside the link. However, we can still inject it right here. Matter of fact, let's copy our previous code and let's click on Go, and it will also execute twice on this page as well. So this was rather simple, but these are also the attacks that we already covered. But right now, I want to cover another attack with the XSS that we didn't encounter yet, and that is the XSS over JSON. So let's click on that one, click on Hack, and this is the application that we get. So we have a single input. It says search for a movie. If we type in movie named test, we click on search, well, the output that we get is test 3 question marks. Sorry, we don't have that movie. What if we try to inject JavaScript code, our regular alert function? We click on search. It doesn't execute. But we do get this part of code right here. Let's go to the inspect element to see where exactly is our script on this page. So let's select this one. Here it is. So we have open script tags. We have var or variable JSON response string, and this could be a little bit hard to read, so let's go and open page source. Let's enlarge this just so we can see it a little bit better, and let's search for the alert function. And here is the script that we're trying to input. It's right here. But it's not executing. We have a similar example as in the previous video. This part of code that we see right here is the part of code that is being written on the page after we try to inject our script. So how can we make this execute? Well, the first thing that you should have noticed, because we did cover it in the previous video, is that in this example, we're already injecting our JavaScript code inside the JavaScript code. We already have these script tags open right here. And we also have them closed right here. So our input is somewhere inside. So one of the things that we need to specify at the start is a closed script tag. But we also have this variable right here that starts with single quote. Then we have curly brackets. We also have the square brackets, another curly brackets. And here where our input is, we have an open single quote. So we must first escape this variable. We want to close all of these brackets in order to continue writing our script outside of this JSON response string. The easiest way that we can figure out which characters we need to specify at the beginning of our command is by going right here and simply copying these characters set. All of these characters are something that we need at the beginning. If we take a look at the source code, we will see that these characters are corresponding to the open brackets and also the double quotes right here and the single quotes right here. And we also have this semicolon at the end to replicate the end of the line that we have in JavaScript code. After that, we want to close our script tags since we are inside of the script, and we want to open another script tags. We can do that by running something like this. And then alert hello. And we close the script tags at the end. So this is our current payload. We have these brackets right here. Close script tags, open script tags, alert function, and at the end, another close script tags. Let's click on search. And here it is. We finally got it to work. So if I go to the source code of this page, and I once again find the alert function, here is our code. The JSON response string is getting closed with these brackets and the semicolon at the end of the line, and then we are injecting our JavaScript code after we close the previous script tags. Awesome. As you can see, there are a bunch of different examples as to how we can exploit XSS, and I advise you to continue with the other examples right here to really grasp the concept of this vulnerability. Nonetheless, thank you for watching, and I will see you in the next lecture. Before we finish off with the XSS section and the XSS vulnerability, I want to just mention one thing that we have within our OWASP BWA application. Now, we do have a lot of these training applications on this virtual machine. But if you scroll a little bit down, you also have old vulnerable versions of real applications. And once you finish through this course and you finish all of these vulnerabilities, you can go through these real-world applications that really existed previously and test for real vulnerabilities that were previously found. For example, since we are in the XSS section, let's try to find an XSS vulnerability on one of these applications. There are many such as Joomla, AWS Stats, TikiWiki, we have WordPress, we have GetBoo, and many others as well. So let's, for example, go with this one. Let's go with GetBoo. We have one search bar. We can go through all of these pages right here, but since we are in the XSS section, this search bar might be interesting for us. Let's type in test just to see what happens with our input. So we get test written right here. Okay. But what happens if we, for example, try to inject a simple script? Let's go. It does get reflected here, but nothing really happens. Let's take a look at the source code. Let's once again try to find the alert, and here it is. Besides there, we also have it right here. So on two different places. Let's go with this place first. So we have open input tags, and our script is being added between these double quotes right here inside of our value parameter. So what would happen if we were to, for example, type in something right here, for example, test, then we manually close the double quotes, and then we add the ending HTML sign to end this entire input part. And after that, we inject our code. Let's see if that would work. Let's go back, delete this, and we type in test, for example, then we type in closing double quotes, then we close the HTML tags, and now we run the script. So let's do it like this. Simple open script and close script tags with the alert function in between. This is our payload, and now if we run it, well, here it is. We get XSS vulnerability in this application. Let's just quickly take a look at the code to see what happened with our input. Here is the input field, and what happened is value is now equal to test. As we can see right here, the input open parameters are getting closed sooner than in real application, and then we are running the script alert function. The rest of the code, which belong to the input function, is getting processed as a regular text. That's why we have it outputted right here. So how cool is that? You can go through these real applications and you can try to search for all of the vulnerabilities that we covered and see which vulnerabilities you managed to find. Nonetheless, we have fully covered XSS right now, and in the next lecture, we're going to start off with another big vulnerability, which is called SQL injection.